Okay, let's just jump right in. What if your phone screen could actually heal its own cracks? I mean, really? Or what if your clothes could change color just based on the temperature outside? It sounds like something straight out of a sci-fi movie, right? But it's actually way closer to reality than you might think. And it's all thanks to this incredible class of materials. So today, we're going to be looking at the future of, well, stuff. The very materials our world is built from. We're diving into the fascinating world of what we call smart or responsive materials. And these are basically materials that are designed to react to their environment in really predictable and really useful ways. So here's what's on deck. First, we're going to break down the secret sauce, what actually makes a material smart. Then we'll get into three amazing examples: a metal that literally has a memory, pigments that can change color on command, and a material that feels the magic of touch. And to wrap it all up, we'll zoom out and look at what all this means for our future. All right, let's get right into it. To really understand all the cool examples we're about to see, you've got to get the one core concept that drives everything. And you know what? It's actually beautifully simple. It all comes down to this one simple idea: stimulus leads to response. That's it. Some kind of external trigger causes a change in the material. This is the secret formula. It's like the basic operating system for every single smart material out there. Burn this into your brain, because we're going to see it pop up again and again. And that brings us to the more, formal definition. That external stimulus we just talked about, it could be pretty much anything: heat, light, pressure, even in electric fields. And the response is that big, controlled change in the material's properties. So it's not magic, not at all. It's more like programmable physics. Okay, so let's see this whole stimulus response thing in action with our first example. I want you to imagine a piece of metal that has a memory. No, really, that's the mind-blowing reality of what we call shape memory alloys, or SMAs for short. You can bend them, you can twist them into a totally new shape, and then with just a simple trigger, they snap right back to their original form. It's wild. So how in the world does that work? Well, it follows our formula perfectly. So step one, you've got the original shape, the one it remembers. Step two, you mess it up, you deform it. It'll just stay in that new shape until you hit it with the trigger. For a lot of these SMAs, that stimulus is heat. You warm it up and bam, that's the response. It just snaps right back to how it was before. And look, this isn't just some cool party trick, right? This is literally life-changing technology. Think about medicine. Tiny little stents made of this stuff can be put into a blocked artery. Then, the body's own heat acts as the trigger, causing the stent to expand and open up the vessel. I mean, that's saving lives. It's also used in stuff like basically unbreakable eyeglass frames and even super advanced parts in aerospace. This is where that simple memory in a material has huge real-world impact. All right, so we've gone from a change in shape to a change in color. Our next category of smart materials is all about reactive pigments. And these are basically materials designed to change how they look in response to something happening in the world around them. Let's break down two common types. First up, we've got thermochromic pigments. The trigger, the stimulus, is right there in the name, thermo, which means heat. The response, you guessed it, a change in color. You've definitely seen this with those coffee mugs that reveal a picture when you pour in hot coffee. Then you have photochromic pigments. The stimulus here is photo, so UV light. And the classic example, of course, is transition lenses in glasses that darken up as soon as you step into the sun. So two different triggers, but a very similar, very colorful response. Okay, our last example for today, this one may be the most mind-bending of all. Let's talk about the magic of touch with something called Quantum Tunneling Composite, or QTC. This stuff has a really unique, kind of bizarre relationship with electricity, and it all comes down to a little bit of pressure. So when it's just sitting there in its normal resting state, QTC is an insulator. That just means electricity can't flow through it. It's kind of like rubber or plastic. It blocks the current completely. It's just inert. But that's about to change. The second you apply pressure, you squeeze it, you press it, you just touch it, the material does something incredible. That pressure, that's our stimulus, right? It physically pushes these tiny conductive particles inside the material so close together that electrons can suddenly do this crazy thing called tunneling and just jump across the gap. Instantly, it becomes a conductor. And get this, the harder you press, the better it conducts. Let go, and poof, it's an insulator again. It's a perfect, instantaneous switch. So what's this good for? Well, this is the tech behind next-generation touchscreens that can actually feel how hard you're pressing. Imagine clothes with the controls woven right into the fabric. You could answer your phone just by tapping your sleeve. I mean, it opens up a whole new world of these seamless, super responsive interfaces.
Okay, so let's zoom out and look at the big picture here. We've seen a metal that remembers, pigments that react to light, and a material that can feel touch. So, what does this all mean? What do these things tell us about our future?
When you really think about it, the common thread here isn't the material itself, it's the ability to react. The true innovation is about building responsiveness right into the very fabric of our world. It's about creating a future where our objects, our buildings, and yeah, even our clothes can sense what's happening and just adapt. And that brings me to a final thought. We have barely, and I mean barely, scratched the surface of what's possible here. Think about self-healing roads or windows that automatically adjust their tint to save energy. The potential is just limitless. So I'm going to leave you with this question. If you look at the world around you, what problem would you solve with a smart material?